Hello and welcome everyone to the Edge AI Talks. My name is Ed Doran. I'm the Vice President of the Edge AI Foundation, and I'm joined by a friend of the foundation, Peter. Peter, how are you this morning?
I'm very well. It's afternoon for me, but I'm looking forward to spicing up my afternoon with a very interesting talk today.
Well, that's the beauty of a global organization. We can cover all time zones, and I agree. Today we're going to be talking about Thor and the neural. Hello and welcome. Today we're at the Edge AI Talks. We'll be talking about Thor and the Neural Branch Challenge. Joining me is a good friend, Peter, and we're very excited to have this discussion today. Peter and I are often talking about the evolving edge of AI, and that often means neuromorphics. We also have these conversations around how do we take these new breakthroughs and get them in people's hands so they can actually work with them and create something new. And of course, the reason that we do so much is because we want to make the world a better place. And today's discussion actually touches on all three things: neuromorphics, having hands on interaction, and hopefully doing some scenarios that make the world a better place with advanced technologies. So I'm very excited for today's talk. Peter, what are your thoughts?
NeuroBench has been cooking for a while and has been the effort of a large number of academics and people from industry. And so it's been a very important topic. Benchmarking generally has been a very important topic in the neuromorphic community, but NeuroBench as an outcome was a fantastic bringing together of a lot of different ideas and a lot of work by various people. I think it's very encouraging to get to the point where that we were discussing also during the creation of that paper and of that benchmark and the entire harness, where there was a discussion about possibly using a standardized infrastructure to be able to run different algorithms so that you could technically compare for that particular system. You could compare even system power to some extent to say how much better a certain application is versus the other one. So it's a very interesting marriage of a very large scale, very flexible system hosted by the THOR consortium and the effort to bring more awareness and bring more structure and better results with the challenge that we're going to talk about today to advance neuromorphics towards industrialization, commercialization, standardization, a lot of Asians to be mentioned there. So I'm very excited.
Yeah, I think it'll be great. I know there will be some people in the audience who are slightly less familiar with this project. So why don't we bring in Taj and team so they can present it, talk about the project itself, and the unique challenge that we're covering this morning. Taj, can you hear us?
Hello. Yes, I can hear you.
Fantastic. Would you like to
Good
introduce the team?
evening. Yes, definitely. Hi, my name is Tej, and I am an AI research scientist at the Matrix AI Institute at UT San Antonio. And I'm actually the lead engineer for the THOR project, which I'll be talking about in a minute. But before that, I'd actually like to introduce two of my colleagues who are going to be working on who we're partnering with on the THOR NeuroBench Challenge. I'd like to introduce Jason Yick, who is a final year PhD student from Harvard University and also leading the NeuroBench initiative. And I'd also like to introduce Benedetto Leto from the Politecnico di Torino University. And he is a research fellow at that university. And he also works with Jason on the NeuroBench framework and has been very involved in its development.
Excellent. Welcome, everyone. So why don't we jump right in and talk a little bit about the program and the challenge?
Oh, sure. Yeah. Let me just share my screen just a second. Is it out? I guess you guys can see it.
Yeah.
Okay, so yeah, so as I said, the basis for our talk today is just to introduce everyone to the THOR NeuroBench Challenge. We're going to be talking about phase 1 in this challenge, so let's get right to it. So most of you are familiar with neuromorphic computing, and the Edge AI Foundation has hosted several talks over the last, so many, I guess, years now, in talking about different areas of neuromorphic computing. And we've seen so many developments in this field, especially with the application and the potential for neuromorphic computing at the edge, with activity monitoring, self-driving cars, and also like smart health monitoring and remote sensing. And we've also seen recent developments in neuroprosthetics using brain-computer interfaces. However, there has been something that has gone amiss. So we've noticed that a lot of these technologies have been developed, but haven't really made it out to the public. So not many people can access this, and it hasn't really made it into the mainstream technologies which are out there today. And the reason for this is twofold, which is, firstly, there's a lack of availability of these systems in commercial markets. You can't just go outright and buy some of these systems. They are either custom made or developed in labs or available in very small volumes. They aren't really off-the-shelf parts. And also, when they are sold, they're sometimes really expensive. And also, the neuromorphic field itself is largely partitioned, and most of these hardware platforms have specialized tools, and they don't really work well with each other. And there have been several initiatives now which are trying to get this field together, and many frameworks that are hoping to achieve this. So here at THOR, we have essentially a mission, and we hope to maintain an open collaborative platform for sharing, developing, and standardizing these systems, tools, models, and datasets, so that we can have advancements in neuromorphic computing research. And we hope to span multiple different application domains. And this is an NSF-funded project. And we have a lot of the hardware that we've acquired, and we're hosting it here at UT San Antonio, which is the lead institute. But this is developed in collaboration with our partner institutes, which is the University of Tennessee at Knoxville, UC San Diego, and Harvard University. So I know we had a talk about this last week, actually, and I would recommend that anyone who's interested in THOR take a look at that talk. That's right here on the Edge AI Foundation's YouTube channel from last week. I just wanted to cover two parts of what THOR has been doing. We have been working on phase 1, which is our system installation of our Spinnaker 2 systems, which happened last year. And then earlier this year, we actually launched phase 1. So if anyone is interested in getting access to these systems, please go to our website and apply for access. So that brings us to our current challenge and exactly the vision behind it. So again, THOR's goal was to establish these reproducible standard benchmarks using open frameworks. And one of those key frameworks was the NeuroBench framework that was very suitable and able to provide these metrics. We also wanted to promote scaling spiking neural networks so that they can span across large-scale neuromorphic systems, and also develop these systems under resource constraints so that they can work not only on large-scale, but also on small-scale systems. Largely, we want to encourage the development of neuromorphic algorithms that can target applications that are useful to society. And that brings us to phase 1 of our challenge, which is bridging this algorithmic innovation with a specific application and making it as efficient as possible. And hopefully that'll bring us to phase 2, where we actually have a hardware realization or an implementation on these neuromorphic platforms hosted by THOR. So I'm going to introduce you to an area of research called brain-computer interfaces. Most of you are familiar with this. Brain-computer interface is essentially a system that translates neural activity into commands for interfacing with external software or hardware. And this competition is going to specifically focus on motor imagery, which are the neural signals which essentially are pass through our motor neurons, which help us control our appendages. They're usually in response to some kind of stimuli, and having that kind of a workflow and that chain will enable this technology to move out of labs and hopefully be useful to people, who are suffering from life-changing disabilities, or such as stroke or ALS or even spinal cord injuries. And hopefully we can help them develop technologies like motorized wheelchair or prosthetics using the algorithms that we developed in this challenge. So, and this has been a notoriously hard area, and with collecting data has also been quite a challenge. And I believe this group, with this publication back in 2019, released this OpenBMI dataset of really high quality EEG recordings, using the whole CAP, really well thought out and distributed across 54 different subjects, and they have multiple sessions for each subject, so that we address the session-to-session reliability issue, which is basically when you have one reading taking place on one particular subject, it might differ due to calibration issues or anything in the setting that is changed from day to day. So having the same subject across multiple sessions is very important for that consistency. Also, there are significant channels so that we get a very large, diverse set of inputs, and then we can focus on multimodal data fusion over here. And then we also address the BCI illiteracy problem, which is the challenge of decoding these EEG signals, which are extremely noisy and very hard to interpret. So this particular data set has data samples inserted over there to make it even more challenging. Now, obviously, data hasn't been modified, but they have included these samples rather than filtering them out. So what exactly is the motor imagery task? Over here, the task will be, it's a very straightforward task where the subject is basically seeing this black image on the screen with a cross to a focus point. And then after a couple of seconds, he is shown an arrow left or right, and the subject essentially moves his hand, his left or his right hand, to actually grasp the object that's been indicated by the arrow. And during this entire cycle, the EEG signals are recorded, and there'll obviously be a pre-phase and a post-phase, and then an actual activity cycle over there in response to these triggers. And essentially, those cues are being recorded and replayed in this particular part of this data set. So our challenge focuses on two particular tracks where essentially, users have to develop a neuromorphic AI model, which is based on spiking neural networks. For track one, which is focused essentially on absolute accuracy. So we don't really have any caps on the model size or the compute restrictions. And we don't really put any restriction on the latency either over here. We're strictly focusing on accuracy to achieve the highest level of accuracy here. So the only conditions here are that the training will take place on the dataset's train split only, and this will be verified for winning submissions. Secondly, these results are averaged across 5 runs on the dataset's test split. And we have a held out test split. And you know what? Jason and Benedito will cover the details of the implementation very soon. Track 2 focuses on compute efficiency. And this is essentially the trade-off between your mean accuracy that you're achieving, as well as 2 metrics which are being measured by the NeuroBench framework, which is synaptic operations per sample, which is synops, or the memory usage, or you can think of it as the model footprint. And it is evaluated using the same conditions as track 1. We thought having both these tracks really opens the door to 2 different types of implementations and different types of optimizations that users will make on their final model. We do have a challenge timeline. So the challenge has already started and registration is already open. So anyone who's listening and interested, please feel free to use the website. We'll be showing you the links to the website, so you'll be able to register over there. And the submission deadline is 31st of July. We have extended the window slightly so that anyone else who is interested can participate. And after that, there will be an announcement of results. And those who have shown significant progress in this will be invited for phase 2. We do have 2 sponsored awards, and I should mention over here that this challenge is being developed and sponsored by the Edge AI Foundation, who will be sponsoring these awards. So we've actually broken up the awards into 2 $500 rewards, one for track 1 and one for track 2. Now I'm going to hand it over to Jason, who's going to introduce you to the evaluation framework.
Thank you, Tej. So Tej has been talking about the THOR
We don't
challenge.
hear you.
How about now?
We can hear you.
Thank you.
Yeah.
Oh, strange. I don't hear anything
That's all right.
from him.
So Tej has been talking about the THOR and NeuroBench Motor Imagery Challenge, and I'd like to tell you about the framework that we're using. Can we bring Tej's slides back up, please? Thank you. So I'd like to tell you about the NeuroBench framework that we're launching this challenge through, and then the participants of this challenge should become familiar with by the end. So Tej mentioned that there's 2 tracks through which this challenge is being evaluated. The first track is for accuracy, and the second track is for compute efficiency. And both of these are easily measured through the NeuroBench framework. So the NeuroBench framework is a code harness, which you can use. It's just all software, PyTorch-based, that we are running this challenge through. And of course, the challenge is, it necessitates a standardized software platform for all of the different participants. This is how we know that everybody is being evaluated on the same set of features. And so the NeuroBench harness provides this software platform, and the metrics that it provides align with the criteria that the challenge is going to be measured on. So that includes accuracy, which of course is very simple, the compute efficiency, which is the number of active synaptic operations that a neuromorphic hardware platform might be using in order to compute for your neural network solution. And then, of course, the memory usage, which is the total amount of model weights and overhead for the parameters. Next slide, please, Tej. So to take a step back from the harness, after this, Benedetto will give a walkthrough of the code in the harness. But to take a step back and look at NeuroBench as a whole, NeuroBench is a large-scale collaborative project meant to be a benchmark framework for neuromorphic computing. So the goal of NeuroBench has been to introduce standard tasks, evaluation metrics, and software for neuromorphic algorithms. And like I said, the standardized software platform is important for benchmarking across different groups in academia and also in industry. So the approach that NeuroBench has taken to build such a platform is to engage the community for collaborative design and emphasize extensibility. Next slide, please, Tej. So in addition to the motor imagery task that we're talking about for today's challenge, NeuroBench also features a number of other algorithm benchmarks, all of which have been tested, evaluated. There is work on new benchmark research for all of these. So on the left side here, we can see the different tasks which are included already in the NeuroBench harness. Of course, the harness is also extensible to any other tasks that you'd like. So these tasks include keyword few-shot continual learning, event camera object detection, activity recognition, motor neural decoding, chaotic sequence prediction, and of course the motor imagery task that we're looking at today. And so you can see that this spans a very wide range of application areas for which neuromorphic computing algorithmic approaches can be interesting. On the right side, I'm showing different metrics which can be measured using the NeuroBench harness. Once again, we're going to go through the NeuroBench harness right after this. Benedetto will lead that walkthrough. And so on the metric side, of course, there is the big metric accuracy. So of course, this is the most important metric and usually the metric that all of these types of software platforms will measure because we don't want to deploy an algorithm that doesn't work. But in addition to accuracy, another thing which is important for neuromorphic computing as a whole is compute efficiency. So this is why these types of metrics are first class in the NeuroBench harness, and it's not only accuracy which is reported. So different compute efficiency metrics are also available through
Did we lose Jason or is it just me?
Yeah. So I think he'll be trying to reconnect. Essentially, I
Okay.
think Jason wanted to cover all the different metrics that NeuroBench does support. And I think he'll be able to pitch in later when, Benedetto is, explaining the harness. I think, when he joins back, he'll probably cover that in a second.
Okay, shall I bring Benedetto back? Because Benedetto, no, he's here.
No, he's here. Yeah.
Okay. Let's see if Jason comes back because I was like, I'm not sure if it's, yeah. Okay.
Yeah. Jason can, when he joins back, he'll be able to cover a couple of different things. So in the meanwhile, why don't I share, how people can register for the event while Jason is joining that. Yeah.
Yeah, that works.
Yeah. Does that
Yes.
sound good? Okay.
Yeah, sounds good.
Okay. So we have the THOR Neuromorphic Commons website, and you guys can join the website and go to the challenge page. It's right in front, and it'll read you to the challenge website. Hey, Jason, thanks for joining back. I'll hand it off to you, and then we can come back to this in a sec. Yeah.
Sure. Sorry about my internet.
Yeah.
So I have one more slide to present. I was talking about the first-class compute efficiency metrics, which includes the footprint, the connection sparsity, activation sparsity, and the metric that we'll be using for this challenge, synaptic operations, as well as a neuron updates metric. You can find documentation and information about how to access all of these metrics through the NeuroBench tutorial and the walkthrough that we're about to do. And my last slide that I'd like to present, Tej, is on a prior research challenge, which we had done, which provided some foundations for this THOR and NeuroBench challenge. So this prior research challenge is the neural decoding challenge, which we ran through the IEEE BioCAS conference in 2024 and 2025. And so, slide update, yes. And so what I'm showing on the screen is a table showing the baseline algorithm approaches that we came into the challenge with. And then the 4 rows underneath are the new solutions that were submitted as part of the challenge. And what you can see is across all different metrics, the R-squared, which is our accuracy metric, improving from around 0.58 to 0.69, as well as different efficiency metrics, including the memory footprint and the synops, which are improving through the research challenge. So the example I'd like to highlight is the second row here, our SNN baseline, versus the second to last row, the RSNN small. And what you can see is this research submission to the challenge achieved a very substantial jump in the R-squared accuracy metric from 0.58 to 0.66 at a similar or even reduced footprint in terms of memory. And in terms of the synaptic operations, even though we see that the dense synaptic operations, which means the number of operations if you included 0 multiplications, while that number increased, the effective accumulations, which is the only non-zero operations from the spiking neural network, actually decreased from the SNN baseline to this submission, the RSNN small. And so you can see how, to my point at the top there, research challenges are launching this new algorithmic research, and this algorithmic research is quantifiably improving. And we can see how over time the metrics of the solutions can get better. In addition to that, what's great about the NeuroBench harness is that these results are all reproducible. So what you can do is at this GitHub link, you can actually find the code that was used to train and to evaluate this RSNN. And you can go check this out and use it for launching your own research yourself. And you can run it on your platform. And because the code harness is all standardized, this is just something that you should be able to do on any machine. So this is why we're excited to be partnering with THOR to launch another one of these research challenges in a new task area, the motor imagery. And next slide, Tej. I'll pass it back off to you, Tej, to talk about the participants and registration.
Sure. So one of the big benefits right now that we are actually, some of the changes that we've made to the challenge since its announcement a few months ago, is that it was initially restricted. The participation was restricted to certain universities. And actually, we've opened it up to all universities, institutes, and groups and research institutes from across the globe. So it's completely open right now, and we welcome all participants. However, there are a few restrictions on the participants themselves, such that participants' teams may consist of 3 members or fewer. Single participant teams are allowed. And we also want you guys to maintain and ensure that you're maintaining compliance with the export control laws of your country, because this is a cross-country competition right now. And this is the link to the challenge website, but I also wanted to show you guys all the 3 different links that we have. So one is to the challenge page itself, where you will see all the instructions and the dates and the timeline. On the left, you'll see the challenge registration website, where you can actually register for the challenge. You need to register before you can actually submit code, because we will send you a special token. And on the right, you'll see the GitHub example repo, which Jason was talking about, where you can actually test out the code. And Benedita will right now be instructing you on exactly how you can go ahead with that. I did want to show you this page, but I think I'll wait until Benedita is done. Benedita, I'm going to hand it off to you.
Thank you.
We lost Benedito, right? Yeah, okay. Let me see if we get hold of him again, and then I'll go again back. Okay, here he is.
I'm
Hi.
back. Sorry, guys.
No problem. I'll go in the background and you can share your screen. I'll bring it up.
Is it up? Okay. So basically, like what I'm gonna show today is available through the link that's in the website of the THOR challenge, or you can find everything into the repository that's on the NeuroBench GitHub link. Everything is inside the example folder and EGI Basically here, like you can find all the code that will help you to start develop your solution. And also like as the first thing that you will see is this README where we describe basically how we pre-processed the dataset, which could be interesting to understand more about the dataset. There is also some instruction about the different files available in this folder. And also something that I want to point out to the participant is the part regarding the reproducibility. In this case, so we ask the participant to seed every source of randomness, but also to export into a file, whatever, like a TXT or a YAML file. They're like dependencies. So basically we can reproduce any codes and reproduce also all the results. So if participants wants to download the dataset, they can go through the Hugging Face link here, and then they can download the dataset. Otherwise, what they can do is that they can use directly this this class here. We developed this object where basically like it's gonna download automatically like the dataset into a root folder that the participant indicated here. There are two different splits of the dataset, the training and the validation split. We held out the test set in this case because that's where the model is going to be evaluated. In this file, the train.py file, you can find a simple training procedure using backpropagation through time of the model. And yeah, basically like in this case, the model is built through the SNN torch framework. In my case, for example, this small model is just a simple feed-forward neural network made of leaky neurons. And what's important here for the participant is that when they define their forward function, the output tensor that they should return should have this structure, which is a tensor of dimension of batch, number of time steps, and number of outputs. In this case, the number of outputs should be 2 because it's just it's gonna classify just 2 different classes. So this is an example like of what kind of model to start from a participant could use. And then like the last part is the evaluation part. So in this part, like basically what we define in this file is the benchmark itself. In this case, we are gonna evaluate the model on the validation set. And that's where you can find here. And of course, the validation set is wrapped into a data loader. Then a participant should define their model and load the weights of the model. Once this is done, something really important that participants should do is to wrap this model inside this class, because this is going to help during the benchmark itself. Once this is done, participant also should define the benchmark object. In this case, the benchmark object should be made of the model, the data loader, any preprocessor, which is like in this case, nothing is defined here, just because like we didn't define any other preprocessing steps in this side. But if participant define extensive like preprocessing, like they could also like include their preprocessors here. In this case, then I included post-processors. In this, basically, like what it does is simply to count the neuron, which produces like the most spikes in this case. And then the most important part is the metric list. The metric list is basically a list of lists in this case. And the first list is made of metrics. There are like called static metrics, which are like metrics that don't require any hooks. Well, then the second list is made of workload metrics that instead require hooks. I think for the challenge, what we are interested is the footprint, the parameter count, classification accuracy, and synaptic operation. Once the object is defined, the run method will run the benchmark, and then you will get the results. Participant will get the results. Yeah, I think this should be it for the tutorial part.
So, Benedito, just to clarify to the users, the held out test set is not part of this, right? That's going to be done on a different evaluation, right? Hello, Benedito? Can you hear me?
Yeah, I can hear you, Taj,
okay.
but I don't have Benedetto.
Okay, that's okay. We can
back.
Okay, sorry.
Just left.
I see. Okay, so we can address some of those questions if someone has any questions at the moment. But hey Benedetto.
Sorry again.
No, you're fine. I just wanted to ask you one more time. So can you just talk about the fact that there is a held out test set that is different from the the train split that you guys have provided from your downloads?
Yeah, so basically like how like the challenge is constructed is that we have all the sessions and all the participants that constitute the whole like domain. And then we split the dataset, the entire dataset, into a train, validation, and test. Of course, in this case, in the LDOUT test set, there are not different subjects, because in this case, the domain, what we are trying to like solve in this task is a subject specific. It's not general subjects. So yeah, that's how the split is done. And also you will have like both session in the train, validation, and test.
That's perfect. We hope to have a high level of integrity and conditionality by having these held out test sets. Okay, so one of the things I wanted to show was exactly how you guys interact with the site so that you can submit your solutions. So let me share my screen again. So if you go to the, just give it a second. I think I'm trying to share something. If can I get the permissions for sharing? Ah, perfect. So if you go to the THOR Neuromorphic Commons website, you can head over to the challenge right here, and it'll lead you to the challenge webpage. So on the challenge webpage, you'll be able to get all this information that we had on the data set, on the task, on the challenge, and the different tracks, as well as the criteria and the different rules about the data set, about the challenge. You'll be able to find the links that we mentioned for registering, for the challenge instructions, the GitHub code harness that Benedito and Jason were just now showcasing to everyone. So it'll lead you straight to their page. You can also directly download the dataset if you guys are interested, but we don't recommend that. This is just for additional curiosity. We recommend definitely using the dataset that has been curated from Hugging Face, which you can access through the GitHub. And also there will be a live leaderboard where you can view your submissions, and it will get updated every day or at the end of every day. And we recommend that in one day, you do not submit more than 3 solutions on a particular day. So please run your tests, but every day you cannot submit more than 3 solutions from one group. And then I'll also want to show you the submission portal. So it's a very simple portal. Please enter your team name that you will create when you register. You will be sent a secure verification code, which I'll be sending out to all the registered teams. And you need to enter that so that we can validate your submission as coming from you. And then you can choose a zip file which is 50 megabytes or 100 megabytes or less in size. And again, three submissions per day at most. Okay, that should cover everything that we have. And if there are changes to the timeline, we will post them here. And any other changes to the rules, we will send out an email. And yeah, thank you so much. I'd like to give a thanks to all the help we've got from the NeuroBench framework and from the Edge AI Foundation for hosting us at this event, as well as sponsoring the challenge. And if anyone has any questions, please feel free to ask.
Well, this was great. Thank you so much for the overview. I know there's some questions percolating in the group. Let me just start with one. We do a number of these challenges, and I talk to people after the end, and they say, "Oh, I didn't realize that. I wish I would have joined." If you had your wish list, who should really participate in this challenge? This is your chance to address the crowd directly and say, if you're interested in X, if you're from Y, if your research is Z, you're really going to enjoy being part of this. So who should really look at this challenge and join the community?
Well, I would have liked to say it's for students and young researchers, but just honestly, the scope of the challenge itself is quite wide-reaching. And the dataset we've chosen is a challenging dataset that has not been used significantly, or I don't think it's been used at all for neuromorphic implementations. I'm not too sure about that. But the benefit of choosing this particular dataset is its applicability in the field and also its scope for improvement. Because if you guys see the baseline results that we have got on this data set, they're significantly lower, and that leaves so much scope for improvement. And since we've actually opened up the architectural side of the type of models that can be submitted, and we have 2 different tracks, this makes it applicable to not just students, but also high-level researchers who want to do significant optimizations on their footprint or model complexity, as well as people who have really mastered the art of fine-tuning their data sets, fine-tuning their models for particular data sets. So I think it's quite a wide range of researchers that this might be applicable to.
Okay, so students and researchers anywhere in the world.
Yes.
Excellent.
And and hopefully it will, this is a purely software-based challenge, but hopefully it will lead to a hardware-based implementation in the future.
Oh, I may have missed that point a little bit, but your main mechanism of getting models is through the submission page on your website, right? Are you looking into potentially linking directly via a different website, for example, by putting them on GitHub or in other places where you would say, I have a particular tag and therefore go and grab it from there and keep it up to date? Or
for the user submissions?
yeah.
No. So the way we structure user submissions is on GitHub, essentially if you're pushing your commits to GitHub, they would need to share a GitHub repository with us, or we'd have to open a shared repository. And we definitely don't want the code that they're submitting to be available to the other participants, at least during the course of the challenge. So that might be something we're doing later on. And also, we wanted each submission to be independent of the previous submission from the same team. So we do, like GitHub, you'd be essentially pushing your changes to the repo, whereas here we'll be updating your runs every day. So multiple runs from the same group will be shown on the leaderboard, and then we'll be grouping them and then getting the best result from each group as well. Technically, yeah, we can do it through GitHub. I guess we could set up a pipeline like that. It's something we'll think about for sure.
Okay, this is very exciting.
Yeah. We have a question from Michael about your validation data. Do we want to put that up on the screen?
I think it's already.
He mentions, is the validation data for the leaderboard distinct to the final held out data at the end of the challenge?
Jason?
So there's going to be 3 splits that you'll have, or that are part of the challenge. So there's the training splits, the validation splits, both of these you have. And then the test split is held out and will be private. When you do a submission, I believe for the leaderboard, that will include your result on the held out test split. So the benefit of making multiple submissions is to check your model's generalizability to the held out test set. So when you make a submission, you'll see your solution pop up on the leaderboard with your held out test set results. And then based on that, you can go back and then try to see if different approaches using the training and validation set can get you better results.
Are you somehow also thinking of supporting other ways of describing models other than SNN Torch, or focusing purely on SNN Torch to begin with? And
so right now, SNN Torch is the closest compatible with the existing NeuroBench harness. But if you work with the NeuroBench harness, you should find it quite simple to connect anything which is PyTorch based. And anything which is PyTorch based does cover a whole lot of neural network frameworks. But in addition to that, you can always use different software framework to train your model and then move that over into a PyTorch reference and then evaluate your PyTorch reference that way. So if you take a look at the GitHub link that I shared on the prior NeuroBench challenge, the group there connected their custom PyTorch spiking network framework to the NeuroBench harness. And you can see examples of how they did it. It's not a whole lot of code addition. Like I said, the harness was built to be extensible in this way.
Okay, so it sounds like it's possible in future if any particular not in future, in the next in next phases of the challenge, and as interoperability standards evolve a bit more, that maybe something like NIR or the neuromorphic intermediate representation or some other representations could also be used, because they do have a backend that should easily export to SNN Torch. And this would also allow some of these repos to be tested a bit more and expanded and worked on.
Yeah,
Yeah,
NIR is definitely one of those frameworks that we would target, especially in phase 2, where we would need cross-hardware implementation capacity from the frameworks, because that'll give a lot of flexibility for the users to submit. But I think right now, since we've already defined the kind of data output we need from your model, I think any model that you use, so long as we can replicate it, and also your output function produces it in that format that is required and testable, I think that should be usable.
That's fantastic. I can't wait to see. Did you cover? I can't remember if you covered at all the limits in sort of sizes and scope in what people can actually define. Like how many resources could people actually take?
So this is a harder thing, since we kept the model size essentially unbounded. We might need to put some kind of compute restrictions on like how long a particular run can take or a particular cycle can take. What do you think about this?
So this is the reason I think that we have 2 tracks. There's the accuracy track and the efficiency track. So the idea, and if you take a look at the example table that I made for the prior NeuroBench challenge, what you can see is that from one team there was a so to say large submission as well as a small submission. And so their large submission was the large model that they were comfortable with training for a longer period of time in order to try and push that accuracy number. And then meanwhile, their small submission was this track 2 focused type of submission, which was trying to achieve both high accuracy and high compute efficiency. So for now, we have no bounds on the amount of compute that can be allocated to any single submission. Maybe there is some submission constraint based on the zip file that we can get from your team. But that would be part of track 1 most likely. And then of course on track 2, we're really looking for the best that you can do with limited resources, which is a lot in the spirit of neuromorphic computing.
But it also sounds like there's a benefit to having the submission portal, which where you can more easily schedule tasks that are not meant to be particularly real time or have a very tight bound on when they're supposed to finish. I'm guessing you have quite a decent amount of resources for how large networks could actually be simulated, and then it doesn't really matter if the updates aren't quite immediate. How often would you expect to update like leaderboards instantaneously as results come in, or
right?
daily?
So we've just finished the portal, and we are going to be building the automatic. We're running the tests ourselves right now, but we'll be, as soon as submissions start coming in, we'll be building an automated testing suite using the zip files that people submit, and it'll run things at the back end. But I'm guessing it'll take, we'll have to see how long, how large these models are and how well they're described and written, right? Because it also depends on how efficiently the models are defined. If they define really large models, which are really poorly parallelized, right? it could take quite a while to run. So we might need to add additional compute restrictions, basically time restrictions on how long one epoch can take on a particular model. Also, I think we'll be essentially evaluating the inference part. Essentially, we won't be training, so we'll be just using inference on there. But the top of the leaderboard will be scanned every week for the ones which are submitting right at the top. We will be verifying those on the training side as well. So yeah.
How much of this infrastructure actually building from scratch versus reusing some of the tooling that already exists? So you said leaderboards. In my head, I'm thinking something along the lines of the kind of competitions that I used to do related to like coding dojo, coding competitions, where you submit a bit of code and there's an automatic verification happening in the background. And
Right.
you
So
perform a little bit.
I'm actually writing everything from scratch right now. So I just finished building the leaderboard, and I will build the automatic testing framework soon. So yeah.
Exciting.
But we are accepting the what do you call the submissions. They're open to submit right now because we have the testing environment already up and ready.
I wish I had an air horn that I could blow to say submissions open now. Come submit.
Yes.
Okay.
Yeah, and we're looking forward to submissions, and I think we've got quite a bit of interest from a lot of different institutes, and we're surprised to see all new institutes. So we're really excited to see the kind of submissions people are going to send in, and it'll be really interesting to see what kind of models they develop, because well, we are all in labs where we kind of focus on one type of model, so it'll be really exciting to see if they have some they reach for something new.
One type of model, you mean mostly that you're focusing on a particular type of lift or a spiking architecture, or?
So, for example, in every lab, I'm guessing there are certain favorites, some models which every lab kind of specializes in or has a proclivity for. So, for example, there might be like reservoir networks or spiking neural networks with added overheads for continual learning and stuff like that. So it'll be interesting to see which direction these models come from.
I can't wait for this to open once again the Pandora's box of what is neuromorphic. Very good.
Yeah. And thank you so much again for hosting this over here.
It was great having you this morning. We have if you had 1 minute to give a piece of advice to those that are looking to submit something to the portal right now, what would you tell them?
Definitely read the instructions. Definitely start by going through the NeuroBench framework and the example that we've posted. I think running that would be your first step, and then identifying exactly what part of the algorithm you guys can improve on, or don't always just go for just increasing the number of layers. That'll just come back to bite you. And don't forget that we have a held out test set, so don't try to overfit your models on the train set. That's the bit of advice I can give you guys. I think that's just generic advice, but yeah, it's still applicable.
It's still good advice. Peter and I need to come up with an air horn or a confetti cannon to launch the opening of the submissions. Jason, Benedetto, any final thoughts?
Looking forward to seeing all the submissions. Please feel free to reach out. You have our contact info in the documentation if you have any questions.
You can also open issue on GitHub if you find any bugs or anything, and we'll help you out.
Oh.
Very helpful, but surely it's all going to just work.
Yes. Well, thank you so much for all of our guests today. This sounds like a fantastic challenge. It'll be really exciting to see what gets submitted and what gets learned and what gets leveraged coming out of this challenge. So thank you to our guests. Also, thank you to Peter as our co-host for helping us today. To the audience, I think this is going to be really exciting to participate in. Let's see where it goes. We also encourage you to join us for other live streams that happen weekly, and we've got some events on the horizons too, where you can come and meet everyone in person. So thank you for your time, and we're looking forward to see what you build. Good day, everyone.
Thank you. Have a nice day.
Thank you.